Any questions about that? This, you've got to have this. Okay? Now, this one. That's number 2 here. This one is increasing, but here it's about 7/8, and here it's only 1/8 or so. You're still kicking it. You're still going faster, but not at the same rate. It's a much slower rate, and it's concave down. Here, this is concave down. Now, in this case, we start going down rather slowly, and all of a sudden we're going down very, very rapidly. Okay, so it is decreasing. You're going from a negative 1 here to a negative 5. That's decreasing. Yes?
Do you have F or F prime drawn there?
Pardon?
Do you have F or F prime?
I have F prime drawn. Those are F primes. Okay? In terms of the illustration here, we have something like this. Oh, let me just take you on a little trip. This is, we're moving some displacement. We're moving somewhere, okay? And this is time. Okay, oopsie, that's time. Time like this. Now, this is what happens, okay? At this point, I'm going nowhere. I'm standing still, okay? And now, at this point, I have a certain velocity. Straight line, probably 50 miles an hour. Okay? Now I'm going to kick it. Go a little faster. When I kick it, I'm going to go this way. I really should take off at this point, but I just did that so you can see it's curving out. Okay? And see, now I'm accelerating, and that's like this over here. Okay? And now I'm going to stop, and now I'm going to kick the car in reverse. Okay? And it's going to be like this. And what happened here is first I didn't have the accelerator down very far, and then I hit it a lot faster, and I was really moving backwards pretty fast over here. Okay? So the red curve, or the green ones too, those are all velocities, or first derivatives. And the fact that they're curved means they're changing rates, so that it's a rate of a rate. Are you with me? And what happens in terms of units, velocity is miles per hour, and acceleration is equal to miles per hour, or miles per hour squared. Okay? Just to give you some units to hang on to a little bit. Okay? Now, this next one we have here is where changes from concave upward to concave downward. That's called an inflection point. Okay? Now, that happens at a particular spot, and I don't believe it's listed here. It's going to be when the second derivative is equal to 0 is a candidate. We've got to talk about that tomorrow a little bit. Okay? Now, so that is an inflection point. Now, here is a test for concavity. We're going to work on this today, and I'll hand out something on that in just a moment. And it says this. If f double prime is greater than 0, then we have it concaved up. And that's like this. Okay? When the value of the second derivative is positive, we're going to have it concave, and your book says concaved up. I usually use upward, but whatever is fine. Okay? So if you notice I'm saying this, it's different than in your book, and that's okay. And I think I use concaved more often than I use concave. Just the way I'm used. Okay? And then if it's less than 0, or in other words, a negative here, then it's concave down. Okay? Now, here's how I remember. If it's concave down like this, that's kind of a frowny face. And then you're going to have something down here in a moment. I'll just say that for down here. Okay? That's what we're going to be doing today. We're going to do this and another first derivative test. Those things. This here, we'll try to take a look at tomorrow. Okay? And that says this, second derivative test. Here's the page on it. And it says we let the first derivative equal 0. What are those things? When first derivative is 0, what do we call those?
Critical points.
Critical points. And f double prime exists on the open interval containing c. Then, at that very point where that is true, if it's greater than 0, we have a local minimum. If it's less than, we have a local maximum. And if it equals a 0, we go back to the first derivative test. We fail. Okay? That we'll do a little bit more tomorrow, and I don't think you'll have a lot of trouble with that one. Okay? Now, Greg, will you pass these out, please? Thank you for taking care of that. Anytime it's out of focus, get it. Oh, okay. Now, I would like to help you just a little bit with a couple of these, and also change the material to just a little bit. So if you're waiting, go to page 243. 243. Notice what I did here. I just made the sheet available to you so you can fill it out this way. This author doesn't do that, although this pattern will fall pretty easily into the way he gives answers. Okay? I also tried to choose a couple that weren't so bad, but a couple of them have a little challenge of finding the derivatives. Okay? Now, take a look at problem 34, the first one that you have to do. And I would like that changed just a little bit. Okay? In the book it says, locate the critical points, no problem. First derivative test, no problem. Identify the absolute minimum and maximums. Are you with me? Because here's a major change. It says in the book on 34, we're going to go the interval from a -2 to 4. Okay? I don't want to go from -2 to 4. I want to do something different. And I would like to go in that interval from a -3 to 4, like this. Okay? Now, you're also going to perform the test here. It says, find the absolute max and minimums. Okay? Now, let's just take that problem. And this point over here is going to be a -3. And the one over here is going to be a 4. Okay? Now, let's just say that this point is going to be a -1, and this one's going to be a 1. Those are the critical numbers. They are not the ones that belong there. I'm just using them so I can show you what this is. This interval is now going to be a -3 to a -1 like this. Are you with me on that? Just helping you see that a minute. Okay? And then this next interval is going to be a -1 to 1. And the next interval is going to be 1 to 4. And we're going to include 4 on that. Okay?
Wait, is this for 34 or 35?
This one is 34.
Okay.
And those are they those for sure intervals? Intervals for that number? Like that problem?
These are not. I'm just saying those are my critical numbers for my illustration. Okay? Now, you're going to pick a number in between here, which would likely be a -2. Are you with me? Okay? And this would be a 0, and this would be probably a 2. Okay? And then you figure out the sign, and then you get a conclusion. Now, your material there says the conclusion is going to be increasing or decreasing. Okay? And then over here, you're going to tell me if that's a local max or a local min.
On the line in between those two?
This here, right here,
Okay, yeah, that's where you write.
that's where I would write it.
All right.
Okay? Local min and max.
So it's in concordance to where the critical points are then?
Okay, we're just going, yeah, okay. Now, these are the critical points, and I'm going to say this is negative, and this is positive, and this is negative. Okay? So this means this is negative going down this way, and it's going up here, so this is a local
Negative
min.
Wait, isn't it, don't you want the negative positive on the line above sign of that?
No, it's a conclusion.
And the equation would be increase or decrease? So you did yesterday.
I like you. Thank you.
The interval teach it.
Just a second. And this is negative. And see, then this is going to be, since this is negative, what do we have here?
Decrease.
Increasing or decreasing?
Decrease.
Okay, this is a decrease, this is an increase, and this is a decrease. Okay, this is decreasing, and so now this is going to be a min, and this is going to be a max. Okay? Yes?
So how come on the way talking you use 4 columns rather than 3? Is that because there were 3 points? Okay.
Yes. Did you follow that? Okay. That's the reason. Okay? And I just made it this wide so I have some option.
Yeah.
Okay? And it also fit nicely across the page, and I thought I'd have enough room in here to do some writing.
Okay.
Okay, now, the next thing you have to do, the third part there, which is the C part, you're going to have to evaluate my original function. You're going to evaluate that original function at a -3. You're going to evaluate it at, from what I'm just doing here, that one, and you're going to evaluate it here, and you're going to evaluate it here. You with me? Okay, now that's the easiest one there is to put it in your TIs and just put the function in there and then go to your table and just read the numbers. Then you don't have to calculate them. If you want to calculate them manually or whatever way you want to do, I don't care. Now, you're going to look at these. The biggest number is the absolute max over this interval. And the smallest one is going to be the relative minimum, or absolute minimum. Okay? Question about that? Okay, now, with that in mind, there is something else in this group. Okay, yes. Let's take a look at 35. That, yes.
For intervals, you just pick whichever number you want them? Or how, because you just made up a -1 and a 1.
I will show you in the next problem
Okay.
how to pick those maximum minimums.
Well, I mean, like, for intervals even, you just choose a number, because you just chose -1 and 1.
That was just saying, I'm saying my problem will give me those as my critical numbers.
You're supposed, okay, can you?
You've got to find the critical numbers.
Yeah.
Can you show us how to do that?
That's what I mean.
Can you possibly do one?
Okay, no, I'm not going to do that one because I want you to have some more experience. Here's my function. F of x equals x cubed plus 9x minus 9x. Like that. That's just it. That's just my function. Okay? Now, Kramer, are you happy or aren't you? No, I'm not happy. Now, I think it's going to be okay to do something easy. Okay? Here's my function. It's a third degree equation, so I know my, oops, I don't even want that. What I want to do is just sketch a little graph. It's a third degree equation, so it could look something like this. Okay? And so there's going to be a critical number here and a critical number over here. And so I'll take the derivative out of this first. Okay? So I go f prime at x is equal to what? 3x squared minus 3. Okay? And so I'm going to factor a 3 out here so you see my method of my choosing my numbers. This is going to be like this, which is going to be equal to 3 times x minus 1 times x plus 1. With me?
So are your intervals -1 and +1?
Yes, right.
Okay.
No.
-1 and 1.
My critical numbers are.
Yeah.
Yeah. Okay. And then the intervals
That's
are.
how you get your interval.
That's how I get the intervals.
Wait, how?
So what are the intervals?
Pardon?
How do you get the intervals then?
Okay. Now my critical numbers are.
1 and -1, right?
Yes, right.
Okay.
And so this one is a -1, and this is 1. And now, just a second here.
If that was a 3x,
Which one?
if that was a 3x and then x minus 1, x plus 1, would it be 0?
Yes, it would. Yes, it would. She's saying if there's an x over here. I could have done that, put a fourth here, a second there. Okay, now, the first problem I have is a -3, 4. That is the interval that I want to talk about. This thing is defined all the way, but I only want this little a to b part. And it's going to be a closed interval. Okay? And so my first interval is going to be from a -3, like this, to
-1.
-1.
Oh, so
And-
you go from the first interval to your first critical number.
But what if you don't, what if you're not given the, interval?
Okay, if you're not given the interval, and that's what we've had in the past, hope you're listening, then we just go negative infinity over here.
If what?
If you're not given an interval.
Could you though, on that interval, can you just say like x is not equal to -1, x cannot equal -1?
No, not very easily.
No?
No, it doesn't work quite that nice. You could write it this way if you like. It says x is less than a -1 and greater than a -3. Those two mean the same thing. Oops,
But then,
this way.
cause like, if you're not given an interval, then you have to do the infinity.
Then you do this infinity one. Yes. And the reason I'm making this change here is because the author does this. He wants that because he wants you to also try to find these, in this case, 4 points and see which one is the biggest, the smallest. Yes.
Does the domain of your function ever change, what you can have as your critical?
Absolutely. And that's going to be my next question.
So you just have to look at the original function to decide that before you do
Yep.
anything else?
Mm-hmm. Okay. Yes, Trevor.
When you put the parentheses by the -1, doesn't.
Are you
that
talking
mean
about this
that
one?
It goes forever. Yeah. What does that parentheses mean then? The bracket means that it stops right there, right?
Here,
Yeah.
it just means that between here we have the critical point of a -1. It isn't included.
But like for the -3, you have a bracket there.
That means it stops there.
But then the
For the
-1 has
-1,
the parentheses.
it just means it never actually gets to -1. It just
Oh,
gets
it's
as
just
close.
like the limit.
Yeah.
Okay.
Thank you. Okay, are we all right on this problem now? Okay. Now let's go to the next one, because you might need a little help with that one, dealing with finding the derivative. Okay? And that's why I chose it in a sense. It's like this, and then we have x minus 4, like that, equals what? Okay, what is the derivative of that thing? Now, we can use the product rule, or we can distribute it. I prefer the product rule. Doesn't matter, you can do it either way. Meaning, you could distribute this over here and here, and then find the derivative, or we can use the product rule. Okay, so now watch what happens here. There's a little bit of a quirk in this thing, and many problems deal with the thing this way. Okay, here we go. So it's going to be the first times the derivative of the second, so we have this. And the derivative of the second is what?
2x over 3.
1.
Oh, yeah, I thought you were on.
Okay, plus, okay. And this,
2x over 3 to the -1.
okay, and this is where you land up with a little bit of a problem. Okay? Now, this becomes a lot nicer if I would write this way. Do I have the right form here to make it halfway decent?
You have x to the negative half, or it should be x to the negative third, right? You go up.
That's there. And then I'm just going to rewrite this like, well, okay, this is going to be 2, and this is going to be x to the -1/3. And then this is going to be x minus 4, and this is going to be a 3, and this is going to be x to the negative, oopsie, this is going to be x to the 1/3 like this, and I'll get rid of this like that. Okay? Now that's that way at this point. Now,
How'd you get that?
I just dropped this. It was negative in the numerator, becomes a positive in the denominator. Okay? At this point, I'd like a common denominator. Okay? So I'm going to multiply this by 3x to the 1/3, and then this becomes 3x plus 2 times x minus 4 all over 3x to the 1/3. Are you with me at that?
Why does it go to 3x?
Because I wanted a common denominator. And so when I did the common denominator here, I have 3x to the 1/3, and this is going to be 3x to the 1/3.
Oh, okay, so
Oh.
since you add them, you get 1.
So little procedure. Now look what happens here. This becomes 3x plus 2x. Do you see that's 5x? Minus 8 all over 3 times x to the 1/3. Are you with me at that point? Yes.
Do you think it'd be, or it'd go over better if you distributed it?
It really doesn't.
It wouldn't?
No. I've done it both ways.
Okay.
My first thinking was it really doesn't make much difference.
All right.
Okay? Now, I just wanted to show you this much, and you can take it the rest of the way. What are my critical numbers?
8/5.
8/5 and 0. Why 0?
Oh.
You can't have a 0 down here.
Why is it 8/5? Because you divide.
I see.
This here says when this quantity equals 0, when y prime equals 0, it's going to be a critical number, and that's here. Or when it's undefined, and that's here. Okay? Okay? That's what I wanted to show you with that one.
So then with the interval for that one, since it's negative 5, 5, so would the first interval be?
You work that out because it's between negative 5 and 5. I have to stop at that. Okay. Now, the next thing I want to do is to do the bottom of the page. Okay. It's a difference. It's quite different there. So listen carefully. Although the two problems for integrating are pretty easy. 47 is easy. I had another one, but I also gave you 55. They're both quite easy to do. Are you with me? Okay, now, here's different instructions. It says for 47, determine the intervals on which the following functions are concave up or concave down. And I want it done on the sheet. Okay? Now, notice the intervals are done the same way. But in terms of the intervals, it's based on when the second derivative is equal to 0. Are you with me? Not the first derivative. You've got to go to the second derivative to get to the zeros. Questions? Okay. Then, as you go down, you get your intervals. Take your test one. Find out what the sign is of the second derivative. And your conclusion will be concave up or concave down. Okay? And if it's changing from concave up to concave down, it's an inflection point. If it's not, it's nothing.
So, what's the inflection point? The interval.
It's going to be under the, like the critical point of the first derivative. This is not called a critical point.
Oh,
It's when the second derivative is equal to 0. Okay? When the second derivative is equal to 0.
Okay.
Now, there's more here than you might think. Okay? But make certain you can do this. Any questions on this? Yes?
Can you do number 26? It was for our assignment yesterday, but can you do like the,
Okay, I will in a moment. And that is, any questions now with this? Yes?
Yeah, can we do one of those?
No.
Why not?
Because it's...
No, not one of those, just
Can we
one
do
in
number
that
26?
section.
Yes,
can we do
yes.
number 26?
Okay, just a second now. Yes, Therese?
And then you said if they don't give us the point, we just go negative infinity to the first thing we find. Okay.
And that's going to be in 47.
Yeah.
And,
That's what.
yes, those are from infinity to
So
infinity.
is that parenthesis? It's not bracket, right?
No, it's
Parenthesis. Yeah.
yeah, okay? Yes?
On those concavity ones with the second derivative, you have to pay attention to the domain and the original function too.
The domain is, both of them is infinite. It's defined everywhere.
But if it
All
worked-
x.
But if it worked.
Oh, yes, you would. Oh, yes. And I did have one where that was the case. That's the trouble of teaching this book the first time. There's so many of these things that you first have to work through, and at 10 o'clock this morning, I still wasn't finished with which ones I had chosen, because I was looking at 37. That's a first derivative one. And like 37, it's only defined from, not including 0, from 0 to infinity. It doesn't have a negative number, but we aren't going to go there. Okay, we've got a question on 26. And 26, I said use your table. Okay, so here we go. 26, and we had here f of x equals x squared times the square root of x plus 5. Hey, this is pretty good too. It goes much like, I think, the other problem we did a few minutes ago. The first derivative of this thing is what? 2x times the square root of x plus 5. And now I'm going to write this way so I can do this in my head, because otherwise I can't do it. And that's going to be plus x squared times 1/2 x plus 5 to the negative 1/2. Are you with me? Times 1. Now don't forget that 1, even though it doesn't matter if you would forget in this problem, but often it's there and then we have trouble. Okay? Now, so I'm going to, this is going to go very much like the one I just did with that x to the 1/3. So we have this here like this, and this becomes x squared, and there's a 2 down here, and we have a square root of x plus 5 down here. Now I'm going to get a common denominator. Okay? And the common denominator is going to be here 2 times the square root of x plus 5, and this is going to be 2 times the square root of x plus 5, like that. And so this is going to clean up to 4x times x plus 5, with me, all over 2 times the square root of x plus 5 plus x squared.
So you multiply it by 2 square root of x plus 5.
What are you talking about? My next step or this step?
That
Part-
step, yeah.
This step?
Yeah.
Yeah, this times this is just x plus 5. Okay? Because it's 2 square roots. And 2 times 2 is 4, and there's the x. Okay? So this turns into 4x squared plus 20x plus x squared, all over 2 times the square root of x plus 5, which equals 5x squared plus 20x. Oh, that's okay. All over
Why is it 20x?
4x times 5.
I gotcha.
Okay? And so this is, I'm just trying to put a lot of steps down. Now this here turns into 5x times x plus 4, all over 2 times the square root of x plus 5. A lot of horsing around. Okay, now what are my critical numbers?
-5, 0, -4.
Okay, you hear that? -5, that's not defined, and then 0 right here, and -4. Okay? Brianna, do you need any more on that one? Okay, yes.
Question back on that table. So after you have your test value stuff, you use
Oh, just a second, DeVries. We're talking about
those
tomorrow.
numbers.
What you're assigned tomorrow,
Yeah,
or
well, on those tables.
okay, yeah,
Those numbers you have for the test value,
yeah.
do you put those back into the derivative or into the original equation?
In terms of the C part.
To find like negative or positive,
Like,
Oh.
once you have
and
these,
then increase or decrease, do you put in the original equation or the derivative?
Okay. Hey, I'm going to erase this now. Yeah, if I need some of this, you can give it back to me. I want to show you something, Derek, to answer your question. I'm looking for, oh, here it is. To answer your question, it's the first derivative test. That's the second derivative test. Okay, right here. Notice you're going to put the thing in the derivative,
Okay,
right here.
alright.
That's an excellent question. Now, the second derivative rule is going to be a little more friendly than this one. But make certain you know how this goes, so you could summarize it for me if I'd ask that. Yes, okay. Next question.
So for the test value, we did
Yes, yes. But to find, see, I first thought he was gonna ask to find absolute maxes and mins. Then you put those numbers into the original equation. Tricky.
yeah.
Okay, anybody, I'm finished with what I have to do. What do you have? Anybody have a question that you wanna pursue? Yes.
It's on, this one's, I can't, so I factored out, it's 34, I factored out,
Yeah.
yeah, I factored out 2d6 x plus 1 squared, or is that's not right? X plus, oh, it's minus, sorry, I mixed up the, I thought it was plus 12, it's minus 12.
Okay. Now, a while ago, I turned Grant off and said, hey, I'm not gonna work on something. I have the time now to do that. Okay, so you have something in, were you gonna pursue something?
Yeah.
35. Oops. Do we need to get the critical numbers there? Right? What were the critical numbers? 0?
8 and 0.
Or
8
negative.
and 0.
These were the numbers?
No, that's 26. It was 8 fifths and 0 and 8 fifths.
Oh, 0, 8
Oh, wait, so there's
fifths.
this point and this point?
That's it. Okay, here we go. And this is going to be a 0. This is going to be 8 fifths. And so this interval, I told you, was going to be -3 to 0. This is going to be 0 to 8 over 5. And this is going to...
It's -5 to 5.
Yeah, it's -5 to 0 for the first one.
Yeah, cause on the book it says.
Oh, yes, right. Excuse me. I was thinking of the other one that I gave you. Gotcha. Good. And this is going to be 8 over 5, comma 5. Okay. Now, a point in here, which is very nice, is probably -1.
Can you use
And this is going to be probably a 1. And this is going to be 3 works. Okay. Now, this is a first derivative. Oh, I don't have the derivatives there.
I do.
What is it?
It's 5x minus 8.
Oh, you can
All
just
over
plug in the
3x.
numbers in the interval.
So the 1 for
And then, so like for this one, you could put
That's it. Oh, that's not bad. Okay, put a -1 in there. And are you watching me on this one, some of you? If you had a -1 here, this is 2 1/3. What is this number? Is positive or negative? This number is negative. And when you put a -1 in here, that's -2. So this is going to be positive. Negative over negative. Okay, now,
Hold on, you put a negative 1 in there on the numerator?
yes,
So would that be a positive 1?
it'd be a -5 minus 8, which is -11.
Oh, okay.
Yeah, that's okay. Okay, now you put a 1 in here. That number is negative, and that one is positive.
So it's a negative.
Okay, and then this one's going to be positive. Now the conclusion here, this is increasing, this one's decreasing, this is increasing, and because of this, if this is increasing and then it's decreasing, this is a,
Max.
and it's local, you
right?
remember.
Local max?
Yeah, and this is going down, and this is coming up, so this is going to be
Min.
a local min.
So where do you get absolute max and absolute
Okay,
min?
then you're going to take your function
Yep.
itself
The original?
at, yeah, your original, at a -5,
Okay.
and at 0, and at 8 over 5, and at f at 5. Okay?
So what do you find with that one? Your absolute?
Yes. Okay? With all the high-powered stuff we have, you'd think, why must we just do those 4 calculations or the calculations at all those points? But that's the first derivative test. Okay? Anything else? Okay, tomorrow we have a shorter class period, and I also intend not to have a terribly long assignment.
You have no assignment?
Yeah, I'm so busy, Mr. Carter.
That's good.
But it's
No.
the end of the quarter.
Busyness is good for boys.
I don't think I have enough time to do all my homework.
I have other stuff to do.
How about this assignment is due Monday?
Okay, so then we collect for 29.
Yeah, there you go.
That right there.
Okay, that's cool. You got choose a nice one there? Oh, this is the other problem. This was new, this is old. Yeah. So, this is minus 4.
You should stop recording.